Once again, I welcome in the course of engineering mathematics. So in the last class, I have discussed about the limit of a function and then continuity of a function and differentiability of a function. So in continuity of a function, I have discussed that a function is said to be continuous at x is equal to a when the left hand limit is exactly equal to the right hand limit and the functional value at x is equal to a that is also equal to the left hand limit and right hand limit. And after that, I have discussed the differentiability of a function, and a function is said to be differentiable when its left hand derivative is exactly equal to the right hand derivative. So today I will discuss the new topic, that is L'Hospital rule. With the help of this L'Hospital rule, I will discuss the problem and then uh, what is mean value theorem, and in mean value theorem I will discuss the what is Rolle's mean value theorem, and then what is Lagrange's mean value theorem and Cauchy mean value theorem and problem based on this theorem. And after that I will discuss the Taylor series and Maclaurin series and problem based on the Taylor series. So let us discuss the L'Hospital rule. So the first, the L'Hospital rule says that if a function in the limit x tends to a fx by gx takes the form of 0 by 0 or infinity by infinity or indeterminate form, we can say, then with the help of this we can use this L'Hospital rule. And according to this L'Hospital rule, limit x tends to a fx by gx is equal to limit x tends to a f dash x by z dash x, and then we can put the value of limit. So let us take the problem based on this L'Hospital rule. So limit x tends to infinity, root x divided by root x plus square root of root x plus square root of x plus so on and so forth. So options are 0, 1, infinite and 2. So if I solve this, so if I take root x common, so it will be 1 plus, and in denominator we can also root x is common, so it will be square root of, and of course limit x tends to infinity, so it will be 1 plus square root of 1 by x plus square root of 1 by x. So it will be root x is cancelled, so 1 by infinity is 0, 0, so it will be 1 divided by square root of 1 plus 0 plus 0 and so on and so forth, so it will be 1. So B option is correct. Let us take the another problem. Limit x tends to infinity, x plus 1 to the power 10 plus x to the power x plus 2 to the power 10, and it is so on and so forth. So x plus 100 to the power 10 divided by x 10 plus 10 to the power 10. So once again, if I x to the power 10 common, so it will be x to the power 10 limit x tends to infinity, so it will be, we can write 1 plus 1 by x to the power 10 plus 1 plus 2 by x to the power 10 plus so on and so forth, 1 plus 100 by x to the power 10 divided by, if x to the power 10 is, once again if I will take common, so it will be 1 plus 10 to the power 10 divided by x to the power 10. So we can write x to the power 10, x to the power 10 is cancelled, so it will be 1 plus, here we can see that 1 plus 1 by infinity is 0, so it will be 1 plus 1 plus, so it is up to 1 plus 1 plus so on and so forth plus 1 divided by, it will be 1, so it is 1, so we can write 100. So let us take the another problem. Limit x tends to a square root of a plus 2x minus square root of 3x divided by square root of a plus 3x minus 2 square root of x. So if I put the value of x is equal to a, so it will be a square root of 3a minus a square root of 3a divided by a square root of 4a minus 2 square root of a. So it is a 0 by 0 form. We can write 0 by 0 form or indeterminate form. So we can apply the L'Hospital, because L'Hospital can be applied in indeterminate form of 0 by 0 or infinity by infinity. So we can apply L'Hospital rule. L'Hospital rule says that if the function is indeterminate, like either by 0 by 0 or infinity by infinity form, then we can write limit x tends to a f dash x by g dash x, and once again put the value of x is equal to a in f dash x and g dash x, and it should not be in the indeterminate form, either in by 0 by 0 or infinity by infinity form. So we can write here limit x tends to a, it is 0 by 0 form, so we have to differentiate. So if f dash x, so it will be 1 by 2 square root of a plus 2x into 2 minus 1 by 2 square root of 3x into 3 divided by 1 by 2 square root of a plus 3x into 3 minus 2 divided by 2 square root of x into 1. Now we can check that whether it is indeterminate form or not. If it is still in indeterminate form by either 0 by 0 or infinity by infinity, then once again we have to differentiate, that is f double dash x divided by g double dash x limit x tends to a. So we can write here limit x tends to a, limit x tends to a, 2 cancel, so we can write 1 by square root of a plus 2x minus 3 by 2 minus 3 by 2 square root of 3x divided by 3 by 2 square root of a plus 3x minus 1 by square root of x, because 2 cancel. So put the value of x is equal to a, so it will be 1 by square root of 3a minus 3 by 2 square root of 3a divided by 3 by 2 square root of 4a minus 1 by square root of a. So if I put common square root of 3a in the numerator, so it will be 1 by square root of 3a, so it will be 1 minus 3 by 2 divided by 1 by square root of a in denominator. If I take common, so it will be 3 by 4 minus 1. So we can write 1 by root 3a minus 1 by 2 divided by 1 by square root of a, 3 minus 4, so it will be minus 1 by 4. So we can write minus 1 divided by 2 root 3 a into 4 square root of a divided by minus 1. So it will be square root of a cancel, so it will be 2 by root 3. So if I see the option, so B option is correct, 2 by root 3. Let us take the another problem. Limit x tends to 0, ln sine 2x divided by ln sine x. So sine, if I put the value of x tends to 0, sine 0 0, ln 0 infinity by infinity form. So it is a, once again, L'Hospital rule we can apply. So limit x tends to 0, f dash x by z dash x. So ln sine 2x, differentiation of ln sine 2x is 1 by sine 2x into 2 cos 2x divided by 1 by sine x into cos x. So we can write 2 cos 2x divided by sine 2x into sine x divided by cos x. Limit x tends to 0. So we can write here limit x tends to 0, 2 cos 2x into sine x divided by sine 2x can be written as 2 sine x into cos x into cos x. So 2 sine x cancel. So we can write limit x tends to 0, cos 2x divided by cos square x. So if I put the value of cos 0 divided by cos, so the value will be unity. So A option is correct. Let us take the another problem. This question is asked in GATE 2008 in computer science branch. Limit x tends to infinity x minus sine x divided by x plus cos x. Limit x tends to infinity x minus sine x divided by x plus cos x. So if I divide by x in numerator and denominator, so we can write 1 minus sine x divided by x divided by 1 plus cos x divided by x. So we can write here 1 minus limit x tends to infinity sine x divided by x divided by 1 plus limit x tends to infinity cos x divided by x. So it will be 1 minus infinity terms, so 0 divided by 1 plus 0. So 1 and 1 is correct answer. Now I am going to discuss the mean value theorem. So in mean value theorem, firstly I will discuss the Rosse theorem. So Rosse theorem suggests that a function fx is defined in the closed interval a to b such that this function is continuous in closed interval a to b, and if dash x exists in open interval a to b, then, and the third condition, that is the functional value at x is equal to a should be equal to the functional value at x is equal to b. Then in between a and b there is a at least one point c such that the f dash c value is equal to 0. So what I said, Rosse theorem suggests that if a function is defined in an interval a to b such that there are three conditions to apply the Rosse theorem. The first one is function should be continuous in closed interval a to b. The second condition, that f dash x exists in open interval a to b, and the functional value at x is equal to a must be equal to the at x is equal to b. Then in between a and b there is at least one point where our f dash c value is equal to 0. Here we can see that this is the function. This is the function I have taken. Here we can see that the function is continuous in closed interval a to b, and the functional value at x is equal to a is exactly equal to the at x is equal to b. So in between a and b there is a one point, at least one point. The point can be more than one, but at least one point where our f dash c is equal to 0. Here I have taken the another example. Here we can see that a function is continuous in the closed interval a to b, and the functional value at x is equal to a is equal to functional value at x is equal to b. So at least one point here, 2 point here I have shown. The first point is c1, that is lies between a and b, and the second point is c2, that is also lies between a and b, and at these 2 points, that is at c1 and c2, our f dash value, f dash x or f dash c1 and f dash c2 must be equal to 0. Second theorem, that is Lagrange's mean value theorem. According to Lagrange's mean value theorem, if a function fx is defined in the closed interval a to b such that the two condition here, function is continuous in closed interval a to b, and the second condition, that is f dash x is exist in open interval a to b, then there exists at least one point c that is belongs to a and b such that our f dash c is equal to fb minus fa divided by b minus a. So firstly we have to check which mean value theorem we have to apply. For Ross theorem, three condition: function is continuous, f dash x is exist, and the third condition that is very important, the functional value at x is equal to a must be equal to the at b. Then we can apply at least one point in a and b where our f dash c is equal to 0. Lagrange's mean value theorem says that these two condition is same as the Rawls mean value theorem. Function is continuous, f dash x is exist, but in Lagrange's mean value theorem, this is not applicable, that the functional value at a is equal to the functional value at b also. Then in between a and b, one point exists, at least one point, where our f dash c is equal to fb minus fa divided by b minus a. Third theorem, that is Cauchy's mean value theorem. So in Cauchy's mean value theorem, two functions is there, fx and gx are two functions defined in interval a and b such that these two functions should be continuous in closed interval, and f dash x and g dash x exist in the interval a and b, and g dash x should not be equal to 0 for all x belongs to a and b. Then there exists at least one point c belongs to a and b such that f dash c by g dash c is equal to fb minus fa divided by gb minus ga. So let us take the problem based on this theorem. With the help of that problem, we can understand in easy manner. So the value of c of the mean value theorem for fx is equal to x cube minus 4x square plus 4x in closed interval 0 to 2 is. So firstly we have to think that which theorem we have to apply, either Ross theorem, Lagrange's theorem, or Cauchy's mean value theorem. So firstly we have to check. So the function is fx is equal to x cube minus 4x square plus 4x. So it is a cubic equation, so it will be continuous in the interval 0 to 2. So function is continuous, or we can check in the interval 0 to 2. Second thing, f dash x is exist. So if I compute f dash x, that is 3x square minus 8x plus 4. So it will be exist in interval 0 to 2. And the third value, compute the value of f0. So it will be 0. And if I compute the value of function at x is equal to 2, so it will be 8 minus 4 into 4, 16 plus 8. So it will be 0. So functional value at 0 and 2 is same. So we can apply the first theorem, that is Rawls mean value theorem. So these three condition is satisfied. The first one is fx is continuous in the interval 0 to 2, f dash x exists in the interval 0 to 2, and the third is f0 is equal to f2, or we can say that fa is equal to fb. So we can apply these three conditions are satisfied, so we can apply Rawls mean value theorem. So what is in between 0 and 2, at least one point exists where f dash c is equal to 0. So we can apply f dash c is equal to 0. Let us where c belongs to 0 to 2. So f dash x is 3x square minus 8x plus 4. So if I compute 3c square minus 8c plus 4 is equal to 0. So 3c square minus 6c minus 2c plus 4 is equal to 0. So if I take common 3c, so it will be c minus 2 minus 2 then c minus 2 is equal to 0. So the value of c is equal to 2 and 2 by 3. But our value, so 2 cannot be accepted because the point c in between 0 to 2. So at least one point in between 0 to 2. So 2 is not acceptable. So 2 by 3 is acceptable. So c is equal to 2 by 3. So if I see the option, so it will be B option is correct, 2 by 3. Let us take the another problem. The value of C of the mean value theorem for fx is equal to 1 plus x square in closed interval 1 to 2. So fx is equal to 1 plus x square. So if I see the graph, so x square plus 1, this is the graph. So here we can see that the function is continuous in minus infinity to plus infinity. So of course it will be continuous in interval 1 to 2. So it is continuous. So function is continuous. If I compute f dash x, so it will be twice x. So function f dash x is exist in between 1 and 2. And the third point we have to check, that is f1 is equal to 1 plus 1, 2, and f2 is equal to 1 plus 4, so it will be 5. So here f1 is not equal to f2. So we cannot apply the Rolle mean value theorem because third condition is not fulfilled. So we can apply here Lagrange's mean value theorem. Lagrange's mean value theorem, because according to Lagrange's mean value theorem, the first one is fx is continuous in the interval 1 to. Second condition, that is f dash x exists in interval 1 to 2, and the third condition, these two condition is satisfied, and so we can apply the Lagrange's mean value theorem. So according to Lagrange's mean value theorem, let C be the point in between 1 and 2, where we can write f dash C is equal to fb minus fa divided by b minus a. So here we can write f dash x is 2x. So twice c is equal to f2 minus f1 divided by 2 minus 1. So twice c is equal to f2 is how much? 5. So 5 minus 2 divided by 1. So twice c is equal to 3. So c is equal to 3 by 2. And this c lies between 1 and 2. We can check. This is 1.5. So it will be lies between 1 and 2. So it is okay. So if I see the option, so it will be 1.5. Third question, that is I have taken the value of C of the mean value theorem for fx is equal to aex and gx is equal to e to the power minus x in closed interval a to b. So here we have two functions are there. So the fx and gx should be continuous. Of course it is e to the power x or e to the power minus x is continuous. And f dash x, that is e to the power x, and g dash x minus e to the power minus ex exist. So here we can apply fx and gx are continuous in the interval a to b. First condition. Second condition, f dash x and g dash x exist in the interval a to b. And the third condition, that is g dash x is not equal to 0, because here fx is e to the power x. So f dash x, if I write, so it will be e to the power x. Similarly, gx is e to the power minus x. So g dash x is equal to minus e to the power minus x. So it will be not 0. So we can apply Cauchy mean value theorem. And according to Cauchy mean value theorem, we can write, according to Cauchy mean value theorem, we have seen that f dash c by g dash c is equal to fb minus fa divided by gb minus ga. So here we have to write f dash c divided by g dash c is equal to fb minus fa divided by gb minus ga. So f dash c is e to the power, f dash x is e to the power x. So we can write here e to the power c divided by minus e to the power minus c, because g dash x is minus, so e to the power minus c is equal to fb. So we can write e to the power b minus e to the power a divided by e to the power minus b minus e to the power minus a. So here it will be minus e to the power 2c is equal to e to the power b minus e to the power a divided by, we can write e to the power b minus 1 by e to the power a. So it will be e to the power b minus e to the power a divided by e to the power a minus e to the power b divided by e to the power a plus b. So here we can write minus e to the power 2c is equal to e to the power b minus e to the power a. If I take minus common, so here e to the power b minus e to the power a into e to the power a plus b. So this will be cancel, minus minus cancel. So e to the power 2c is equal to e to the power a plus b. So here we can write c is equal to a plus b by 2. So if I see the option, so it will be a plus b by 2. So the value of c is a plus b by 2. Another question I have taken. A rail engine accelerates from its stationary position for 8 seconds and travels a distance of 280 meters. According to the mean value theorem, the speedometer at a certain time during acceleration must read exactly. So here we have to find the speed. So here interval is, here we can see that interval is 0 to 8 seconds. And function is continuous because a rail engine accelerates from its stationary position from its 8 second and travel at a distance of 280 meter. So we can write let st be the distance. So we can write s dash t is equal to s8 minus s0 divided by 8 minus 0 according to Lagrange's theorem. So here because the value at the distance at t is equal to 0 is not equal to the value at distance at t is equal to 8 second. So we can write s dash t is equal to the distance at 8 second is 280 meters. So it will be 280 minus 0 divided by 8 minus 0. So it will be 280 divided by 8 meter per second. And s dash t means ds by t, so it will be velocity is equal to 280 by 8 into 3600 divided by 1000. So it will be how much? it will be 126 kilometer per hour. For which of the following function mean value theorem is applicable? So here mean value theorem, the two conditions that is same in each, in three mean value theorem, that is function is continuous in the closed interval a to b and the f dash x should be exist. So here we can see that fx is equal to tan x. So function is not continuous in 0 to 2 pi interval. Fx is equal to tan x is not continuous in the interval 0 to 2 pi. If I draw the graph of tan x, so let us assume this is the so it will be like that. Similarly, so it is not continuous in 0 to 2 pi. If this is 0, pi by 2, pi, 3 pi by 2, so it is not continuous in 0 to 2 pi. Similarly, if I draw the graph of y is equal to mod x minus 2, so function is at, this is x is equal to 2, this value is 1 and this value is 4. So function is not differentiable at 2. So f dash x will not exist at x is equal to 2. So this is all, we cannot apply mean value theorem here. Here we cannot apply. Here fx is equal to x minus 1 to the power 1 by 3. X minus 1 to the power 1 by 3. So if I compute f dash x, so it will be 1 by 3 x to the power x minus 1 to the power 1 by 3 minus 1. So f dash x is equal to 1 by 3 x minus 1 to the power minus 2 by 3. So it will be 1 by 3 x minus 1 to the power 2 by 3. So f dash x is not exist at x is equal to 1 because the interval is given 0 to 3. So it will not exist f dash x at when x is equal to 1, the function approaches infinity f dash x. So the third option is also discarded. If I check fx is equal to x minus 2 to the power 2 by 3, fx is equal to x minus 2 to the power 2 by 3. So f dash x, if I compute, so it will be 2 by 3 x minus 2 to the power minus 1 by 3. So it will be 2 by 3 x minus 2 to the power 1 by 3. But it is not exist at x is equal to 2, but interval we can check, it is 4 to 5. So 4 to 5 f dash x is exist. In the interval 4 to 5 f dash x exist in the interval 4 to 5. But here if I write the comment, so f dash x does not exist in the interval 0 to 3. So our we can apply the mean value theorem applicable. So in this function we can apply the mean value theorem. Now I am going to discuss the Taylor series. So Taylor series of fx about x is equal to a is given by fx is equal to fa plus x minus a divided by factorial 1 into f dash a plus x minus a whole square divided by factorial 2 f double dash a plus x minus a to the power 3 divided by factorial 3 f triple dash a, so on and so forth. So if I put the value of this a is equal to 0, so the function can be converted fx is equal to f0 plus x f dash 0 plus x square by factorial 2 f double dash 0 plus x cube by factorial 3 f triple dash 0 plus so on and so forth. And this function is called Maclaurin series. So with the help of this method, we can expand any type of function. Let us assume the first function, that is e to the power x. So e to the power expansion of e to the power x is 1 plus x square by factorial 2 plus x cube by factorial 3 plus so on and so forth. So with the help of this series, this method, we can expand, like fx is equal to e to the power x. So the f0 is equal to unity. Similarly, f dash x is equal to e to the power x. So it will be at x is equal to 0, once again it is unity. So with the help of that, we can expand the series. Similarly, the second function, that is sine x. So the expansion of sine x is x minus x cube by factorial 3 plus x5 by factorial 5 minus x7 by factorial 7 plus x9 by factorial 9. So with the help of this Taylor series or Maclaurin series, we can expand any type of function, like cos x. So the expansion of cos x is 1 minus x square by factorial 2 plus x4 by factorial 4 minus x6 by factorial 6. Similarly, here the function is ln 1 plus x. So ln 1 plus x is x minus x square by 2 plus x cube by 3 minus x4 to the power 4. So if I take any example, how it is coming. So let us take, I have taken e to the power x. Function is e to the power x, and we have seen that fx is equal to f0 plus x divided by factorial 1 f dash 0 plus x square by factorial 2 f double dash 0 plus x cube by factorial 3 f 0 plus so on and so forth. So firstly I will compute f0. So f0 is equal to e to the power 0, it is unity. Similarly, f dash x, if I compute f dash x, so it is once again e to the power x. So f dash 0, it is unity. Similarly, f double dash x, it is e to the power x. So f double dash 0 is also unity. Similarly, f triple dash x is equal to e to the power x. So if I compute, it is unity. Put the value of these derivatives. So fx is equal to f0. So f0 e to the power 0 1 plus x by factorial 1. So factorial 1 is unity. So it will be x plus x square by factorial 2 into f double dash 0. So value is unity, plus x cube by factorial 3 plus x4 by factorial 4 plus so on and so forth. So here we have written the expansion of e to the power x. We can see that. So with the help of that series, it is very easy to expand. Similarly, any function we can take, the expansion of 1 plus x to the power minus 1, it is 1 minus x plus x square minus x cube plus x4 minus x5. So fx is 1 by 1 plus x. Similarly, we can compute the f dash x, f double dash x, f derivative of third, and put the value of compute the value of all the derivatives at x is equal to 0. So we will get this expression. Similarly, the expansion of 1 plus x to the power minus 2, that is 1 minus 2x plus 3x square minus 4x cube plus 5x4. Similarly, we can also expand this type of function and by Taylor method. So let us take the example based on the Taylor series. In the Taylor series, expansion of e to the power x about x is equal to 2. The coefficient of x to the power minus 2 to the power 4 is. So according to Taylor series, we have seen that fx is equal to fa plus x minus a divided by factorial 1 f dash a plus x minus a whole square divided by factorial 2 f double dash a plus x minus a whole cube divided by factorial 3 f triple dash a plus so on and so forth. Okay, so here we can write fx is equal to, at x is equal to 2, so we can write f2 plus x minus 2 by factorial 1 into f dash 2 plus x minus 2 whole square divided by factorial 2 f double dash 2 plus so on and so forth. So firstly we have to find the value. So fx is equal to f2 plus x minus 2 divided by factorial 1 into f dash 2 plus x minus 2 whole square divided by factorial 3 into f double dash 2 plus x minus 2 whole cube divided by factorial 3 into f 2 plus x minus 2 whole 4 divided by factorial 4 into f4 2 plus so on and so forth. So we have to find the coefficient of x to the power minus 2 4. So x to the power minus 2 4, what is the coefficient of? So coefficient of x to the x minus 2 to the power 4, that is, what is the coefficient? So this value, this is the coefficient. What is this value? 1 by factorial 4 into fourth derivative at x is equal to 2. So function is e to the power x. So function is e to the power x. So derivative of f4 x is equal to e to the power x. So f4 at x is equal to 2 is e to the power 2. So it will be e to the power square divided by factorial 4. So if I see the option, so it is C option is correct. Let us take the another problem. For the function e to the power minus x, the linear approximation around x is equal to 2 is. So linear approximation we have to take at x is equal to 2. So we can write according to Taylor series, fx at x is equal to 2. So fx is equal to f2 plus x minus 2 divided by factorial 1 into f dash 2 plus x minus 2 whole square divided by factorial 2 f double dash 2 plus so on and so forth. So we have to take the linear approximation. So these two term is linear term. So linear term is f2 plus x minus 2 into f dash 2. So if I compute, fx is e to the power minus x. So f dash x is minus e to the power minus x. So the value will be linear approximation is equal to e to the power minus 2, because fa is f2 is e to the power minus 2 plus x minus 2 into f dash 2. So it will be e to the power minus 2 into minus 1. So it will be, if I take the common e to the power minus 2, so it will be 1 minus x plus 2. So it will be e to the power minus 2 into 3 minus x. E to the power minus 2 into 3 minus x is the correct option. Another question that is asked in GATE 2008. In the Taylor series expansion of, so fx is e to the power x plus sine x. About the point x is equal to pi, the coefficient of x minus pi whole square. So once again we have to apply the Taylor series. So according to Taylor series, fx at x is equal to pi. So we can write fx is equal to f pi plus x minus pi divided by factorial 1 f dash pi plus x minus pi whole square by factorial 2 into f double dash pi plus so on and so forth. So we have to take the coefficient of x to the x minus pi to the whole x minus pi whole square. So coefficient of x minus pi whole square. That is, here we can see that the coefficient of x minus pi is whole square is 1 by factorial 2 f double dash pi. So it will be 1 by factorial 2 f double dash pi. So firstly, function is e to the power x plus sine x. So f dash x is e to the power x plus cos x. F double dash x is e to the power x minus sine x. So f double dash pi is equal to e to the power pi minus sine pi. So it will be e to the power pi. So coefficient of x minus pi whole square is equal to 1 by factorial 2 e to the power pi. So it will be 0.5 exponential pi. So B option is correct. So in the next class, I will discuss the maxima minima concept and problems based on the maxima minima.